This is What is This Black Magic? An Intro to Macros and Annotations in Scala. I was trying to think of what would be a good, catchy title for this, and I can't think of a better word than black magic to describe it. So before I start, who has any familiarity with macros within Scala? Sweet, so this will be fun. It's magic. So what are they? So macros in general are a form of metaprogramming. The idea is that you can use code to generate code. And indeed, they are magical. So one of the common reasons that you would use a macro is you want to encapsulate some common code that you want to carry throughout places, but you don't want to have to write the same thing over and over again. So you write a macro to make your life easier. Because as programmers, what do we love more than writing code? Not writing code. So to understand kind of macros in a nutshell, it's part of the compilation process. So a fair criticism that I have heard people say of Scala is it takes a long time to compile. They're not wrong. Part of that is the compiler is doing a lot of things for you to save you from yourself. And as a result of that, depending on how you write your code, you can actually make the pain worse for yourself. And I'm going to talk about that a little bit shortly. But generally speaking, these are the phases that whenever you run sbt compile, it goes through all of these steps. And so part of this is the type checker, which lumped into that is macro expansion, which is the places where your code that you wrote to generate code kind of gets expanded out. And another part of that is implicits. So a lot of the magical things that we do in Scala to make our life easier happen in those first early stages. And as a result, can influence how the stages downstream, kind of how long they take. The other advantage of macros is that you can use them not just to generate code, but you can use them to, at compile time, basically build in checks to make sure that your code conforms to a specific pattern. So first off, compiling code. So here's your source, hello world. Really simple, basic. What the compiler does is it takes that string and it converts it into an AST that looks something like that. I don't want to write that. I get scared when I look at that. But what's really cool is by converting your code into this AST, it can then do some pretty cool transformations and inspections on it because it has a way that it can understand your code. And also, it allows you to do things like use an IDE and do jump to definition and find the source code because it's broken it into this representation that it can link everything together for you. So a little history of macros. They were introduced in 2.10. And the original plan was to have them be experimental and then in 2.12 be an official part of the language. Spoiler alert, that did not happen. What they actually found out really quickly was there was some really interesting use cases that people found for using macros, and they didn't have a clear idea of what the API definition of that should look like within the language. So they created a whole foundation dedicated to kind of formalizing the API. And at the time, the only way to enable macros is actually through a compiler plugin. And all the compiler plugin does is basically add this extra functionality for you, and you opt in by either using an import or adding it into the Scala C compile options. What's really awesome is in 2.13, you won't need a compiler plugin to use macros. So from 2.13 forward, it's actually going to be a dedicated first-class citizen. It's still experimental. So the API still can change and kind of evolve, but they're recognizing that there's actually some really cool things by making it a first-class citizen. You can actually speed up the Scala compiler, and you can actually make it work a lot better. So that this also kind of paved the way for the new Dotty compiler backend that's going to happen in Scala 3. So lots of fun, cool stuff there. So I use macros. You want to reduce boilerplate. So for example, most people have used macros in their Scala code base, usually in relation to JSON reads and writes. So instead of having to write out, here's how I go from my Scala case class into JSON and vice versa, it can automatically kind of do that for you at compile time. And it makes it so if you change your classes and stuff, you don't have to remember to rewrite things. It's pretty nice. Connected to this is annotations. So probably almost everyone here has used the @tailrec annotation. So what this does is uses macros to basically say, hey, I said this method is tail recursive and you can optimize it. And so it does a check that says, is this method actually something we can optimize? And if not, the compiler will fail and it'll give you a nice little warning. So I'm going to show you guys what this looks like. If I can actually remember how to use PowerPoint. So I'll make this a little bit bigger. Everyone can read that? So a macro, they're sometimes referred to as def macros because it's like a method definition. So you define your method, and then you have this macro, and then you point towards an implementation. And then your implementation looks like this insanity. So this is an example from the play.json repo. This is all the things that it's doing to go from your case class into that beautiful JSON read writes. And in tailrec, oh, look at that. There's our annotation. And then again, there's all this code that all it's really basically doing is breaking apart that abstract syntax tree and doing the checks to say, is this something we can optimize? So one of the things with macros is there's a context around them. So in the first iteration of Scala macros, they just had Scala reflect macros context, and this context was used for everything. And what they found out is actually macros, you have to reason about them in two different ways: black box macros and white box macros. The idea is that with a black box macro, you are chaining yourself down a little bit more. You're saying, these are my inputs, and these are kind of my outputs, and we want to follow those types, and it matters. So most macros fall into the black box category. Then there's white box macros, which is basically free for all, do whatever you want. The compiler just kind of, you could tell it that the return type is X, but it's really a best approximation that the code it's going to generate is X. There's not kind of, you can do things to not guarantee that. So annotations, the way this connects is you can do macros without having annotations. And you can do annotations without having macros. It's all about kind of what developer experience you're trying to provide. So annotations, anyone who's done anything with Java EE is pretty much familiar with, Spring Boot and things like that, where you're at rest, at JSON get, and basically you define the bare minimum code, and then it transforms out all the wiring of oh, well, this is, needs to have an HTTP context, and it supports get operations, and it writes that code for you so that you can focus on the fun problem-solving-y things, not the repetitive boilerplate-y things. The other advantage of that too is you're not doing copy-pasting as much because you're letting the compiler do it for you. So in theory, the code that's generated is, not going to have as many errors because you've kind of abstracted away those common things, and you've said, no, this is how it'll always be. Follow that pattern. So the way I'm going to kind of do this is I'm going to show you guys two different examples that show black box and white box macros. Does anyone have any questions? So the first example I'm going to use is a process timer. So it's pretty common, when you're checking out the optimization of a piece of code you're writing, is you want to know how long does this thing take to run. You can solve this without using macros. You can solve this without using annotations. But there's some added benefits you can get if you go the route of doing that. So I'm going to show you some code. That's now 2 times I've forgotten to exit out of PowerPoint. Okay, so can everyone see that, or do you guys want me to make it a little bit bigger for you? Okay, so the way you'll commonly see Scala libraries that provide macros set up is you have a project that's the actual macro implementation, and then there's another project that's the actual kind of like test suite. Because you have to kind of have those things separated out a little bit. So like I said, since we're dealing with a prior to 2.13 version of Scala, we have to enable it by adding in this compiler plugin, the Macro Paradise plugin. And by doing this, that basically gives that extra little phase where the macros I write, the compiler will expand them into the code. And this statistics and print, what I'm going to show you guys is I'll actually compile my code, and it'll print out to the terminal what it's generating in terms of the actual source code that it's writing for me. And so pretty simple little project. We have the macros, and then we have our examples. I have the examples depends on macros. And another cool thing I'm doing here is I'm cross-compiling. So I'm saying this macro that I'm making, compile it down for 210, 211, and 212. So the code. So the idea here is I want to say @processTimer on a method. And when I run my code, what I want to see is it's going to run it, and it's going to tell me at the end, it took this long to run my method. And so macros, the way you do them is you kind of use this what's called quasi-quotes, which anyone who's done string interpolation in Scala, it's the same exact concept. It's basically a pimped string context where you have $, and then each of the variables represents something contextual for the AST that you're extracting out. So in the case of this guy here, what I'm saying is take out my method definition, and then rewrite my code. And rewrite my code like this. So I'm going to have any modifiers. So is it private? Is it override? Whatever. Def, my method name, any type arguments, my actual arguments, my return type, your method body, and so this ... $body, what this does is it unquotes and expands out whatever the method body that you provide is. So basically what I'm doing is I'm taking whatever method that I annotate, and I'm saying rewrite the actual definition, put these imports, and start, cast the result as the variable result, the body as result, get the end time, then log out the runtime, and then return my result. And so if I put this annotation on something that is not a method, it will immediately abort the compilation, and it will say, hey, annotation @processTimer can only be used with methods, because it's the only thing it makes sense to use it for. So you're looking at about 10 lines of code here that basically I can put this anywhere in my code base, and it's going to, at compilation time, rewrite my code to inject this in. So you could accomplish this by doing it as a function and using call by name parameters and get this same exact behavior. But the advantage to doing it this way is, say you only want to use this process timer when you're testing something out. Because we're using a logger, we can disable the logging of the process timer by just turning off logging. Or we can just comment out the annotation. And it's one line you have to comment out. Whereas if you were to do this with a method that you kind of just like passed in your body to. You get into the whole thing of like, well, you got to comment out 2 lines. Then you have to deal with, oh, well, what if I want to reuse this across different files? I got to do this import. If I want to use it across projects, then I got to duplicate that code or put it in its own library. So the actual usage of this looks like so. So a process timer, and then whatever your method is. And so you put it on the method, and then each one of these invocations is actually going to go ahead and it'll rewrite it. So let me come here and make this code a little bit better, visible, project. Examples. And yeah. So I'm going to compile that. Oh, wait, no. Wrong one. Project root. Dead. Yeah. Live demos. Let's try this again. Enabled. Oh wow, you really don't want to work. It's on that one. Okay, I'll come back to this. I was trying to get it to show the actual compiled code it wrote, but anyways. So project is examples, so run. So I'll run the process timer demo. And so you see here where it actually, this is the code that I wrote in that macro, where it executed it and then logged out.
So if you have a, is it statically also compiling the content that was in the strings?
Yep.
Okay, so that's a compile time check then, not a runtime check.
Correct. So at compile time, you are getting all of your type checks and everything happening. Because it's a black box macro, any of those type parameters that you pass in, it's going to verify that those line up with the code that it generates. So I think if I were to actually use those types within the macro, that's where you would actually see, like, if I tried to use those types in an improper way within the macro, it would abort out. But because I'm not doing anything fancy with it, it's like, yeah, you're cool.
So the imports that you're putting in, you put some imports in there. Is there a possibility that those could conflict with what's in that method, and can you deal with that?
So the question was, how do you deal with like conflicts if there's actual imports in the code that's getting generated? So I'm glad you brought that up. So one of the things that I did with this definition is I imported Java time. So that's pretty safe. Like, Java time should exist. But, added SLF4J. That could be a problem. So one of the things that I did is, not in here, but I actually have published out this as a library. And in my actual library definition, or no, I did do it here. So when you're doing your dependencies, when you're building a library, whatever dependencies you list when you package your jar, if you do a fat jar, it is going to pull all those in. But if you do this provided, what that basically does is it makes it not actually pull that dependency in as part of the resolution. So what this is effectively doing is it's saying the project that's using this library must provide this dependency. And so since I'm using the SLF4J API, this lets me use whatever logging backend I want to use that conforms to the SLF4J, the simple logging facade for Java. So like you can see here where I'm using logback, but I could swap that out. So at compile time, if I didn't have that in there, I'll reload this. So this is kind of cool. So Scala, whenever you start your SBT session, whatever your definition of your build.sbt or build.scala file is, that's what it loads up in memory and is using within your shell session. So if you make any changes to your build definition, you need to make sure you explicitly call reload so that it kind of reboots its shell session. So now if I compile, it compiles fine, but at runtime, I'm going to get a runtime error. Because it's going to say, hey, it doesn't have that. No class def found. I'm sure there's a way that I could rewrite this so that it actually checks it, but it doesn't. So in this case, it's a runtime failure, not a compile time failure, not having that dependency.
Are Scala macros hygienic? Like if I have, in your example, you have the body that's being injected into the snippet of code that you have in the macro. If I have an identifier that's named the same thing that appears in the body, is it hygienic or is it gonna have a conflict at compile time?
It should have a conflict.
Okay.
So what'll happen is when it goes to expand the code out, it'll see the duplicate named parameter. So like for example, if I had val start defined within my actual method by that I was passing, it should compile. So let's actually test that out, because I'm pretty sure that's what actually should happen. But so it should clash when it's expanding that out. Yeah, it might actually end up being a runtime thing that it would do. So let's see. So our expectation is it's going to compile fine, but it'll blow up at runtime. Oh, now it's showing what I want it to show. Okay, so because I have the statistics on, and now it decided to actually work for me, it's logging out each of the things that it's doing as it's compiling. And so what we can see here is result start. So you can see where, yep, because it's doing it as a block there. So actually it won't clash then, possibly. Let's see what happens when we actually run it. Yeah, oh yeah, that's right, because I gotta add that dependency back in. Load.
So it's actually thinking about like the imports. So the imports would have a problem if you had a duplicate import with the same name.
Yes, I think you were right. It would have a problem there. So compile. Nope, it's totally cool having the same variable because it wraps that in a block. That's kind of neat. I did not know that. But yeah, this is an example of what I was saying where like it actually generates that code for each invocation of it. So, like I said, they're magic. They kind of just do their thing. And here's an example of and I got a compile error. And there's my thing where it aborted out at that phase. When I was practicing for this, IntelliJ would actually complain about this and be like, no, you can't do it. But today it decided it doesn't want to do the right thing. So this is an example of where we're using an annotation and kind of macros together to add in some kind of like pimped functionality that lets us, kind of instrument our methods. And again, because it's wrapped in logging, we have complete control over it to turn it on and off either by, enabling or disabling it in the logging, or you could comment it out if you wanted. So that's the first example. So the next example I'm going to show you guys, it's a really fun one, string obfuscation. So the idea here is we're going to have a case class, we want to annotate it, and we want to say, these fields, when you call the toString method, we don't want to actually log them out. Say, password or credit card. It'd be pretty bad to, have those leak out in your logs. So I'm doing a super simple thing. I'm just replacing whatever the value is with a star. But the meat and potatoes of this is we provide arguments to our macro, which are going to be a list of fields that we want to obfuscate. And then what we're going to do here is the generated class that it makes, it's going to override the toString method that it normally would generate. And it's going to do that by, this is actually basically ripped out of the Scala compiler internals. This is actually what it usually uses, is this toString implementation. So in this version, what I'm doing is I'm actually rewriting the code so that in the place of where it's going to access out those properties when it calls toString, it's going to replace their actual value with stars instead of whatever it actually has. When you call get or set or whatever, it's not going to affect that. It's just going to be for the instance of when it calls toString. The problem with this is that you can only operate on strings because of the way this is implementing it. So I made a better version, which is instead you can provide the fields, and then we're actually going to iterate through the declared fields and just obfuscate it in the actual method body of that toString. So we're not going to use whatever magic the Scala compiler would normally do for rewriting those things, and we're going to isolate it just into our custom definition of toString. When I was practicing this, I was like, man, it'd be really cool if Scala provided a way without reflection to get the field names. And it turns out in 2.13, there's now a product elements. So you can call, since the early days, there's been product iterator, which lets you iterate through the actual fields that you have on your case class. But there's no way to get the actual name. It just gives you the value. Product elements gives you the actual name of the fields. And so then what you can do is you can actually zip together the iterator and the name so you could create tuples of name and value, which is kind of cool. But again, only in 2.13. So the way this actually looks when you're actually using it is you pass in the string of things that you want to obfuscate, and then it'll custom generate that toString method. And so we'll run this guy, and we will run the first one. And here we see when we just call print line with the instance of the case class, it's replaced it. But again, if I explicitly call, give me the value of that field, it's going to log it out. I'm going to show you, so this is for the purpose of the examples, I have a V1 that doesn't support fields that aren't string. So obfuscate, clean. And so what we see here at the compile is it's going to say, oh, hey, it found a string, but it needs a long. And that's because what it's doing here is, so let me comment these other things out so it's a little bit easier to say. There's all this nasty, nasty stuff that it writes, but is that copy? I'm trying to find where it is specifically. So there's actually, so what's actually causing that error is when it rewrites the body, it actually, and it's not showing up in here, but it'll say field name equals that value, which in the case of that first one, it's casting it to a string, but it knows that the actual definition on the case class is a long, and so you get a type error on that because it's trying to basically rewrite the assessor in the case class that's generating, and understandably so you're getting a type error. So there's a quick little kind of change to make it so that it could support whatever type of field. And you can also, in my test that I created here, I show where it can actually do, you could have nested things as well. So like if I do my test user and I use that obfuscation on it, when I create a case class that has an instance of that and I call toString, it'll obfuscate that instance. So it works with nested ones too, which is kind of cool. Again, it's a super like toy example, but it shows you kind of the power of being able to encapsulate this functionality that you want to carry throughout your code, and you don't have to copy paste. If you want to add some extra kind of things into it, there's one place that you have to change, and you kind of are guaranteeing that it carries throughout. So as part of this, I got really excited. I was like, yeah, if I'm going to do this example, I might as well like make this available. And of course, the internet will die on me. Alex, is it Starspace 64 or guest? Guest. Cool. And the password is just password, right? Techlahoma capital T? There we go. Sweet. So macro talk. So I have this on GitHub, and you actually can use this library if you go to Maven Central. I publish it for 2.11 and 2.12. And so you actually use it if you want. Or you can, create pull requests, or you can troll me and tell me things that you want on it. So part of the inspiration for that process timer was actually at a Python project I did, and I wanted to know how long certain phases of it were taking. And I figured out basically how to do this in Python, and I was like, that was really cool. I want to do that in Scala. And so that was kind of like what led to that example. One of the things that is really interesting about macros is you can really go down a rabbit hole in trying to understand how they work and what you can do with them. But one of the biggest eye-opening things for me in doing this project, this presentation, was realizing just how much little things you can do in your code base that can actually speed up your compilation time. So for example, if you explicitly give type returns on your variables and all of your method names, the compiler has to do less inferring, which is going to be one improvement that works for you. So in small code bases, like in this project, I tried where I actually didn't do method returns, and it took 2 seconds to compile. And when I put in method returns, it took 1 second to compile. So not a big, order of magnitude for a small code base. But if you think about as a code base grows over time, that can add up. Well, where this really, you start to see the benefits of actually not making the compiler infer the types is when you are using a lot of macros, or you're using implicits, or the holy grail, implicits and macros combined. Because you are effectively telling the compiler, hey, this is what it should come out to, so it's going to trust you that you know what you're talking about, and so it won't try and infer it, and it's kind of less work that it has to do to help you. So the biggest takeaway that I had from doing this is that you should really be aware of anything that's public, publicly scoped. You always should have return types. Even though it's really easy, especially with variables, not to do it, that little boost that it'll give you as your code base grows is totally worth it. Anything that's privately packaged, so it's just within your library, no one else can have external access to it, it's okay to not have return types on those, because what you've effectively done is you've minimized the surface area of where the compiler has to do its inference, and it's actually pretty smart and intelligent about being able to pick things together. Another thing that's really cool that I learned from this is that you should really keep up with the upgrades that SBT has done. So SBT, prior to version 1X, did this thing where every time you start the SBT compiler and it warms up a JVM and it's waiting there to do its thing. Well, every time you do a compile, it's recalculating the world, it's redoing its thing. It really sucks at it. It's not optimized. With SBT 1X, they've actually switched to this kind of server backend, where you can actually have multiple SBT things, multiple SBT projects up, and multiple SBT compilations going, and they'll actually share a common server backend for compiling. So it's actually a little more less make your computer hate you and fans go off the rails. It's still got some quirks if you have a really big code base. I've noticed if you do tilde compile, so it'll watch and recompile on changes. If you have a really large code base, it's very easy to exceed the heap and crash that compiler server. That's one of the things that they're working on improving in the newer ones. But that's what I got. So questions?
Yeah, do you have any good practices on what you should or should not put into a macro?
Yes. So don't put implicits into a macro. Whatever you put into a macro, it should be a very concretely defined thing. So if you think about functional programming as I give these inputs, I get these outputs, and you can reproduce it, and you want to try and keep everything pure, you want to do that same mentality in terms of your macros. You want to be able to have it be something that you can reason about easily, and not make it do a bunch of magic behind the scene. You should be able to look at the code and say, this is what it does. The other thing I would say is there's so many really good libraries out there that leverage macros that you should start being conscious of what dependencies you're bringing in and what they're potentially doing under the hood, and what the benefits or pros and cons are of that library versus maybe another library, because there could be some benefits that you get by using one library over the other just because of how they're accomplishing something under the hoods. So that was something I never really thought about before. I was just oh, well, this library does what I need, and I like it. I like the way it works, so sweet. I never really thought of oh, wait a minute, I could maybe improve my compilation time if I use this other library. I'm looking at you, Scala Z versus cats.
sorry. I had a couple things. So this looks a lot like in Haskell, there's template Haskell, and this reminds me a lot of it. A couple of things that happen when you use a lot of template Haskell. One is that you end up with a lot of compiler dependency, and I noticed that you had a big list of compilers. Is that something that you should be watching out for when a new version of the compiler comes out? You might have to rewrite your macros.
Yeah, so actually, that's a good question. So notice how I said that my library, in the toy example, I said I was going to cross-compile for 2, 10, 11, and 12. I specifically left 13 out for a reason, and that's 213, since macros is specifically a part of the compiler, what I would have to do is either put a bunch of conditional things in my build to exclude that compiler plugin just when it's doing 213, or I'd have to create a separate project that's 213 specific. So I would say think about the versions of the languages that that you need to support. Like if you're just dealing internally within your company, the likelihood of you needing to support multiple Scala library versions is probably pretty low. You're probably consistently on the same version. But if it's something that you're putting out to the public that you're maintaining, you do have to be aware of compiler changes that could potentially break whatever, if you're doing something that's specific to that compiler version. So like that product iterator, the product elements, like that's something I could put in, but if I wanted to use that, I would basically have to have a 213 flavor of my library to use that, and then the 210 and.
Yeah. And one more question on the type. The annotations seemed really interesting. Are anyone using that to maybe have like type system extensions in addition to performance extensions?
I cannot think of an example, but yes, I think you can do that. You can use, so annotations are kind of interesting in that by themselves, they aren't really generating code. It's more about tagging information on. But if you use them in combination with macros, yeah, you could do stuff like pimp out your type system, do more crazy stuff that isn't currently supported. And that's actually how a lot of I think the path-dependent type stuff in earlier versions of Scala, that's actually how it kind of is accomplishing some of that. It's using some macro expansions. Yeah. Type classes is another perfect example of where macros are usually used under the hood, and you don't really think about it. Any other questions? Sweet. Well, thank you guys. It was fun. And like I said, I have the code out on GitHub, so if you want to use it or you want to give any feedback, by all means. So thank you.
Thanks, Brandon. That was awesome. And thank you all for coming today and doing the survey feedback. We got so much pizza back there, so take a box. I don't care. There are also a lot of donuts, so help yourself out. And we'll see you next month. Thanks.